Okay. I am Leonidas Pesinas, and I'm a research assistant here at Strathclyde University. We will have a presentation together about the supply chain of liquid natural gas. Supply chain is very important for the existence and the efficiency also of LNG, as it specifies its availability at the vessels in order to use them as marine fuel. Nowadays, of course, there are some obstacles to the adoption of both in the supply chain and the infrastructure of supply in ports. However, the next years, we are thinking that we will overcome these obstacles. We can note that, for example, for 2020, we are expecting that we will have approximately 1,000 of LNG fueled vessels. So, in order to have the feasibility to supply all these vessels, we have to have appropriate equipment and appropriate infrastructure, and of course the supply chain. We should note here that as European Union is co-financed our program on the MoS Way Network, we should note that is also co-financed a wide number of such projects that will help to the construction, to infrastructures, to the ports, and also to the LNG vessels for retrofit or for new buildings and things like that. If you would like to divide the supply chain in two big categories, we should do it like this. We should call the first category as upstream sector, that includes the exploration and the mining. And the second category should be the downstream sector, that includes all the other processes from the existing of LNG to the transfer to the final user, who is not another than the LNG fueled vessels. Indicatively, we're talking about processes like production, processing, liquefaction, transportation, and the final distribution of natural gas to LNG fuel vessels. So in order to start, we should describe first the upstream LNG supply chain. We should say here that we collected some elements from BP statistical surveys about the countries all over the world, about the production of LNG and the consumption of LNG. First of all, we will talk about the production, and we can say that the global production increased by 1.6% in 2014, in contrast with the previous year. In this year, US as the country with the largest production, with 728.3 billion cubic meters, increased by 6.1% in contrast with 2013. North America had the largest regional increase in production with 5.3%, in contrast also with the previous year, 2013. We're talking about 2014 due to the fact that we have not elements for 2015, because these elements are published at the end of each year. So the year that we can talk about is the previous one. As for Russia, decreased its production to 578.7 billion cubic meters, which is a figure which is 4.3% less than the previous year. Europe and Eurasia followed the same exactly way, with Russia reduced their production by 3.1%. At the following slide, we can see also the statistical survey, some statistic elements about the consumption of LNG. First of all, we should say that the natural gas consumption has increased slightly by 0.4%, while the highest increase between the consumption of high consumer countries has the China with 8.6%, followed by Saudi Arabia 8.2%, and Iran 6.8%. Here we should also mention another key element that, for example, there are countries that it has a bigger ratio of increase. For example, Turkmenistan is 21.1% increase in contrast with the previous year. But we are talking about high consuming countries. For example, we can think here that China has 200 billion cubic meters of consumption, while Turkmenistan, that has so big raise, has 27.7 billion of cubic meters. So this is why we are talking about China and Saudi Arabia. As far as the European Union is concerned, we can see that there is a large decline in gas consumption with 4.8% compared with the previous year. And in this point, we should note that UK consumed the largest volumes, the largest portions of LNG the previous year, with Germany and Italy to be the two other countries that follow UK in the consumption of LNG. We can also observe what we described previously about the production and the consumption of LNG for the last 25 years, from 89 to 2014, divided by region in billion cubic meters. And we should state that national gas constituted the 24% of primary energy consumption in 2011, and we're talking about European Union, and is expected to reach to 30% until 2030, while the petroleum products reach at 38%, coal 23% of the primary energy, and nuclear 12%. At this slide, we can see also the major trade routes that LNG uses in order to have a transfer from one region to another. With the blue arrows, we can see the roads, the ways that LNG follows in order to transfer from one country to another. And over these arrows, there are the figures that means how many billions of cubic meters we have transferred from one region to another. As far as the LNG import terminals, we should state that there are a lot of import terminals in all over the Europe. For example, we can find import terminals to Italy, to Greece, to Spain, Turkey, UK, Sweden, Norway, and other countries. However, we can see that the bigger number of import terminals of LNG, we can find them at Scandinavian countries, and especially Norway, where, as we can see in the map, there are already 40 existing terminal of LNG, especially for small-scale facilities. And what are we talking about when we are saying about the small-scale facilities is about storage capacities that reaches until 1,000 cubic meter per storage capacity. So we should mention that the total storage capacity when we are talking for Norway is approximately 2 million cubic meters. All these key elements make Norway, as we can understand, a suitable country for the adoption of LNG as marine fuel. We can understand this if we see in the map, for example, the blue circles. It may not be so easily to so visible, but we can see that all these blue signs is about the existing LNG terminals in Norway, and the yellow and red signs is about, for example, the planned LNG terminals, not only in Norway, as we can see, but also in other European countries. So we can understand that there are plans for having widely the LNG for the next years. In this point, we can see which is the major difference between the Norway that we described earlier with UK. For example, and this is about a case study that we did at Strathclyde University the previous year. For example, we can understand how difficult is for a Grangemouth terminal if we try, for example, to retrofit it to a LNG terminal, Grangemouth. This was the study about, and we will talk about this the following Wednesday. How difficult is to supply Grangemouth terminal with LNG due to the fact that the shorter distance in order to carry the LNG to Grangemouth terminal is T-Sport, and T-Sport is 150 nautical miles away from Grangemouth. This process for transferring the LNG from T-Sport to Grangemouth should be done almost once or twice a week. So we have to do this process quite often. And this is why, as we said, it's quite difficult and time consuming. So, as we said earlier, and as we can see in this map here, we can observe a map with 23 existing LNG terminals. This is a map that we got from GLE, and we can see with the green color the 23 existing terminals, and with the red color 5 terminals that are under construction. As far as the yellow color is concerned, it's about the 24 terminals that are under study or planned. We can also understand here that there are some efficient terminals for LNG, but the big thing is that they will equip properly the following years, while at the meanwhile there will be a wide construction of important number of LNG terminals. European Union had realized that bunkering operations and the bunkering infrastructures are very important for the wide use of LNG. So you can think how marine companies and ship owners can use their LNG fuel vessels without having the opportunity of using bunkering stations like what we described earlier. This graph is a graph that we also presented at the previous presentations, but I decided to put it again in order just to see and to focus on the gray area. The gray area is showing how is planned to increase the storage capacity in Europe, which is another clue that, as we see, there is an increasing flow. So this means that it's another clue that ensures that it is planned the next year to use the LNG widely. As far as due to the fact that we have closed the chapter of upstream LNG supply chain, we should pass to the next chapter, which is the bigger between the two of them, and it is the downstream LNG supply chain. So, as we said earlier, this covers all the steps between the production of LNG until it's transferring to the end user, which is the LNG designed, the LNG fuel ships. So we can find here the various options for supply, and that we will describe at the following slides. And we will now explain what are the definitions used to describe what is described as large, medium, and small scale handling LNG. So, from this table, we can see three different situations about the large scale, the medium scale, and the small scale. First of all, we should try to explain what is intermediary terminal. Intermediary LNG terminal is used if the distances between the import terminal of LNG and the end user, the port that is used in order to bunker the LNG fueled vessels, if this distance is very high. And what this means high? High means it's not economically feasible to cover without an intermediary station. What distance can be not economically feasible is 100 nautical miles if we are talking about the sea, which is 185 kilometers, and 500 kilometers if we are talking about roads. So it would also be interesting to note here that intermediary terminals may vary to their capacity, as they can also see to the table. And this depends to the use that we need this terminal. For example, there are terminals that are used for high frequency ports, and there are terminals that used are fishing ports, for example, that we have fishing vessels. So at the large scale, as we can see from the table, we see that as onshore storage, we have the import terminal that will be larger than 100,000 cubic meters of capacity, while the ship that we will use in order to cover all these necessities of this large-scale scenario is between 100,000 cubic meters to 270,000 cubic meters of LNG carriers. In this situation, we can understand that we cannot use a tank truck, because the tank trucks are 40 to 80 cubic meters, which is a very small volumes when we are talking about the large-scale scenario. As for the medium scale scenario that we can see at the middle, there we may use an intermediary terminal, which capacity depends from 10,000 to 100,000 of cubic meters, and the ship size that we will use in order to transfer the LNG will be from 10,000 to 1,000 cubic meters capacity. 1,000 to this should be a mistake. Is 1,000 to 10,000 cubic meters. As far as the small scale, we may use an intermediary terminal, which will be less capacity than 10,000 cubic meters, while the LNG bunker vessels can be like the previous at the medium scale, or can be smaller, like 200 to 1,000 cubic meter. In this situation, we can also have tank trucks, especially in a situation that we will not need so many, so big portions of LNG. Now, as far as the small and medium-sized LNG carriers for refueling, some of them we were talking at the previous slide, we should state that the small and medium-sized LNG carriers are required in case of further distribution of the LNG import terminals via intermediary station, as we said previously. So there are three categories. The first one is LNG bunker vessels, the second one is LNG feeder vessels, and the third one is barges with or without self-propulsion. At the right side of this slide, we can see an LNG bunker vessel, which capacity is 2,800 cubic meter of LNG, and it is 80 meter vessel. Let's talk about the LNG bunker vessels, which are the vessels that used more nowadays, and the expectations that they will still use them at the future. So we can see some characteristics, some features of this type of vessels, that they allow the smaller and flexible movements within the ports, which is a major advantage. There is the propulsion is possible with two azimuth thruster to ensure a unique maneuverability. In this point, we should say that the azimuth thruster, as we know, give the opportunity to rotate the propeller, so we do not need to have any rudder, and this is why the maneuverability is easier. Their capacity ranges from 1,000 to 10,000 cubic meter, and transfer both LNG and fuel oil. The last is that they may use LNG as fuel, making this type of vessel environmental friendly. Here we can see the video about Argos GL. It is an LNG bunker vessel that it is designed, and it have not published yet. They expecting it until the end of 2015. It has the very interesting thing about it is that it's the first combined bunker vessel, where something that means that it can carry also LNG and deliver both LNG and marine diesel fuel oil. So it has a capacity of 1,870 cubic meters of LNG and at the same time it has capacity 1,400 cubic meters of diesel. So we can see the video. This is also a project co-financed by the European Union, as we said earlier, one of these projects. This is what we said earlier about the azimuth thrusters that has the opportunity to rotate in order to giving the opportunity of good maneuverability within the port. We can see the cell concept. We can also add here that Mark III membrane is used for containment for the 4 Type C tanks, as we can see here. It's Type C tanks. We will have the opportunity on Wednesday to have a full presentation about the tanks of LNG from representative of GDP, which is a major company about tanks, especially for LNG. So we have the opportunity to find all the characteristics of the vessel that is designed and will be delivered at the late this year. So this was a video that for the first time we have the opportunity to be presented at the conference in Amsterdam about LNG bunkering at January of 2015. So, continuing for the small and medium-sized LNG carriers for refueling, we can find the next category, which is LNG feeder vessels. We cannot find so many differences with the LNG bunkering vessels, but we should note that their basic aim is the regional distribution of marine fuel LNG by large import terminals to points along the coastline. The size and the dimensions vary according to the market demands, the depths, and the physical features of the port. The typical capacity is bigger than the bunker vessels that it was 1,000 to 10,000. Here is 7,000 to 20,000 cubic meter of LNG, and it should have both thrusters and high performance rudder. It would also be preferable to have dual fuel engines in order to increase the backup propulsion. And this is also another difference with LNG bunker vessels that may have, for example, only LNG engines. About the third category of vessels that we can use in order to distribute the LNG to the end user, to the terminal, for example, is the barges. The barges has the characteristic to be self to have self propulsion, or not to have self propulsion. They may be environmental friendly, and the low fuel oil consumption is also a result from the boil-off phenomenon that we will describe at the next presentations. It is also efficient, as we can understand, because they are smaller than the previous vessels that we described. So this is why there are quick turnaround at loading and the discharging the ports. And here we can see the design of an LNG barge. We can have it now. Okay, so here is the video that about the backing brace and how we had the opportunity, for example, to see the bunkering life of backing brace, and to also see some characteristics. There are two LNG tanks, type C tanks, that where there is the storage of LNG, and all these are parts that will be described step by step all this week. From the tanks to the engines. So this is why we will not stay in describing the parts of backing brace, but for us in this step, the important thing is this one, the bunkering operation. So we can see how is the preparation of backing brace in order to have the bunkering operation, and here is the small bunker vessel that is going close to the backing brace in order to have the correct connection for the bunkering operation. Here is the hose that will be connected. It is used dry connected coupling. We will see later why it is important for this operation. As the employees at Viking Grace said, it is an extremely safe operation. They are doing this every day, almost every day, 6 days a week, for 3 years, and they didn't have noticed any problem. This 15 minutes is about the bunkering, but the bunkering is It lasts almost an hour in order to do the connection, to disconnect, to be sure that they will make this connection safe in order not to have the problems that you said earlier. And somewhere here, the operation has finished. In order to be safe, they make sure that everything is closed. And SIGAS, which is the bunker vessel, is going away, having completed the, the bunkering operation. So, as we saw from the video, it was used dry disconnect couplings. Dry disconnect couplings have some advantages. Guarantees both the highest level of safety and also the quickest way of connecting and disconnecting. This means why it's necessary during a bunkering operation. It is also environmental friendly as there has no possibility of accidental spillage, and it is very easy to handle as we can see at the next video. There is it needs only a push and turn in order to have a free flow, and then turn and pull in order to close the connection. Since this connection is closed, this means that the valve closes automatically, and, it cannot open again. So it can characterized by reliability. This is not in a vessel, in a ship vessel, but it is useful just to see how it operates a dry disconnect coupling from very short distance. And the reliability that we said earlier is a big issue if we think how many things a lot of people saying about LNG all the previous year about the safety of LNG. They were worried about if it will be safe or not. So parts like this in the main operations of LNG on bunkering, on transfer and things like that, giving a clue and the proof that it is safe enough in order to use it as marine fuel the next years. Apart from all the other advantages that we have, for example, about the environmental friendly characteristic of LNG, things like that. At the left side, as you can see, it's the old way of connecting and disconnecting during the transfer of LNG, and at the right side of our screen is the dry disconnect coupling. So this is what we said earlier. The major advantages is it is very easy to handle, especially for people that are doing it every day, and of course that it is safe and environmental friendly. As far as the safety breakaway couplings that we can see, they are typically installed into loading arms and hose assemblies. Um, and they prevent from pull-aways accidents. They protect terminal and loading and unloading equipment and eliminate unwanted product release. We have also the opportunity to watch how this safety breakaway cabling is operates. So just in order to have an idea about what is. So here we can see how we have the normal flow, and if there is a problem, there is this disconnection where it is automatically stop the flow in both sides. So this was what we had to say. Some words about how the vessels operate in order to transfer the LNG through the sea. But there are also other ways in order to transfer the LNG. So there are also some special tankers for regional LNG distribution. The LNG trucks can be used especially for small scales customers. As we said earlier in the table, we saw these trucks, these loading trucks at the small scale scenario. So we can note, we can mention the operation of trucks, especially in regions that they are not connected with gas transmission network. The vehicles can carry between 50 to 80 cubic meters of LNG, depending on the size of the trucks that are available in this specific country. Um, a typical refueling process can last up to 2 hours, including the completion of required documentation about the safety procedures and all these things. But the pumping time is the rate is about an hour, as the transfer rate is 60 cubic meter per hour. So the whole process may last 2 hours, but we can understand that the second hour is about all the secondaries processes without having in our mind the pumping time. It is also an economic solution if we think that the investment cost it's range from 350,000 euros to 500,000 euros for a typical tanker, and we can now observe a special truck and how it operates, how we have a bunkering in from a truck to a vessel. So these are the special trucks. The equipment is used is almost the same with the vessels that making this operation by sea. You can also see the hoses. For the operation. We can see that it needs a lot of time for small volumes of LNG. So the last way of transferring LNG from a terminal to the LNG fuel vessels is LNG transport via pipelines. It is a very difficult process, but it is also very expensive. Uh, the use of this type of pipelines is limited, and we can understand that we need an infrastructure at the whole terminal in order to have this type of process. Um, as we can understand, due to the fact that the LNG pipelines are onshore, we cannot use these pipelines for very long distances because it will be very expensive to have these pipelines for so long. So the LNG solutions for LNG bunkering, we can see them to these pictures and we can analyze them. We know that the infrastructure is at Europe is at a very early age, and the technical and operational aspects of solutions for the supply of ships are under discussion. However, there are three main ways of bunkering the vessels that use LNG as main fuel. This is ship-to-ship operation, the truck-to-ship operation, and the LNG terminal to ship operation via pipelines. Actually, there is another one, another way of refueling operation, that it is the mobile storage tanks, but they are not widespread as this choice depends on several aspects, several factors like distance, traffic, intensity, required volume, frequency, safety, and all these things. So all these aspects should be taken into account in order to have a successful operation. We can also see in this picture the solutions for LNG bunkering. And we can analyze, as we said earlier, the ship-to-ship bunkering operation. The supply made by ship-to-ship can be performed when the ship is on dock, anchorage, or sea when the vessel is in operation. The second, the second choice about the sea, it depends on weather conditions. So we should pay attention if there are strong winds, waves, if there is the proper visibility, and other factors. There is also a need of suitable buffers and appropriate quality and quantity of mooring lines. And of course, the refueling system is designed in such a way that permits the safe and efficient movements between the vessels involved. For operational reasons and for efficiency of time, we can realize that the quantities of LNG that need in order to have this type of operation are more than 100 cubic meters of LNG, and only for these quantities we can see that this is a logical choice for having a ship-to-ship operation. And the average bunkering time it is 150 to 200 cubic meter per hour. So we can understand that it is quite fast way of bunkering operation. If we would like to have a typical scenario about a ship-to-ship operation, we can have a RoPax LNG fueled vessel for short distances, which is suitable for having LNG as marine fuel, and the refueling in port is considered to be near urban areas. The basic requirements for this scenario are the high levels of safety and, of course, their fueling time. So the required amount of fuel is set to 130 cubic meters of LNG, which is almost equal to 65 tons of LNG, and the maximum time is considered to be at 50 minutes in order to have the bunkering operation. So we can see how this process of bunkering is divided in three parts. The first one is before bunkering, it lasts almost 15 minutes. The middle one, that it is the actual process of bunkering, it lasts for 25 minutes, and the last one about 10 minutes, which is after bunkering. If we talk, for example, about other type of vessels, and not for this type, for an Aeropax vessel, for example, the time the time for refueling and of course the portions, the volumes of LNG change. As about the second type of bunkering operation, the track-to-ship bunkering, the supply of special design tankers is currently the most widespread form of ship supply with fuel LNG. We can understand this due to the fact that, as we described in all previous slides, the most of the infrastructure that we have available now in all over the world is for small scale scenarios. So as we said that trucks can cover the LNG for small portions, we can understand why the trucks for bunkering are the most widespread scenario in contrast with the other three. So the main advantage of the tank is that they are specially shaped to be cheap compared to the others. As we said earlier, it costs 350,000 to 500,000 euros, but it is cheap if we can think that it may an LNG banking vessel may cost, for example, 10 million of euros. However, there is a significant drawback. This type of process is a slow process. If we remember well, we can understand that it needed 3.5 hours at the previous video for the vessel in order to do the operation. 3.5 hours in order to have almost less than 100 of tons of LNG. And this method it is not fast enough, as we said, as its average rate is 40 cubic meters of LNG per hour. So it is suitable for small fuel volumes that are not bigger than 200 cubic meter of LNG capacity. At this point, we should mention that the site that we have chosen for refueling should be linked by road, and this filling station should have special facilities for the loading and unloading process, and we are talking about to have proper roads in order the truck to can carry all the tanks near to the LNG fuel vessels. As far as the LNG terminal to ship, which is the last way of refueling, is a method ideal for high rates, as we can see, and for average large fuel quantities. When we are talking about high rates, we're talking about 500 cubic meter of LNG per hour, and it is extremely high if we consider that the LNG bunker vessels have the capability of transferring 200 cubic meters per hour, and the trucks have the capability to transfer, as we saw earlier, 40 cubic meters per hour. So it is almost 12 or 15 times faster than the trucks. But as we said earlier, it's a very expensive way. It is also an appropriate solution for ships that operate in frequent voyages due to its velocity in refueling, and it's with a short duration, and also for ports that can be characterized as high frequent ports. Depending on the requirements and the choices of the logistics of the size of the LNG storage, it ranges from very small 20 cubic meter LNG capacity to very large, to more than 100,000 cubic meter of LNG. The main limitation in this way of refueling method is the distance from the refueling point. The long distances make it hard to carry this process with piping, for example, and this issue means lack of flexibility. So this is why in a lot of ports that have the terminal to ship option of refueling, use some barges in order to complete the refueling operation. At the last slide, we can see which is the advantages and the disadvantages of the three supply modes as we described them earlier. The ship-to-ship operation, it is flexible with the high transfer rate, as we said, to almost 200 cubic meter of LNG per hour, and the ability supply large quantities of fuel. And of course, it can do the refueling by sea. The disadvantage is the high investment and the operating costs. In contrast with, especially with the truck-to-ship operation, that we also have flexibility, but we have small fuel quantities and lower transfer, and about the last one that we described in the previous slide, the terminal to ship via pipeline operation, where we have no flexibility, but we have fast supply, and we have an expensive way of refueling method. And that's it.
Thank you very much. Any questions? You may ask also our internet students if they have any questions. Email to the camera. Questions?
Of course, if there is any questions.
Actually, we should take a picture of the students here. You could, of course. So you will become famous. Let me know. Let me know. Yeah, please prepare yourself.
Straight back.
Yeah, just move. Yeah. And like that. Okay. Okay. Any questions? Yeah.
When we design a bunkering LNG bunkering system, the maximum velocity is not going up to 10 meters per second because it may cause steady electricity. But in your case, many cases, for example, for truck bunkering, it goes up to 40 meters per second. It's more than 10 meters per second, I guess. So, is there any measures to reduce, to minimize or remove the static electricity considered?
I have to check specifically regarding this, but my understanding is that the materials and the way the pipes are built is such that it prohibits the formation of any static, and also obviously the very low temperature is playing a significant role in that. But I have to check and confirm to you. Okay.
On what you said, the numbers that are provided are cubic meters, not velocity. So if you have a larger pipe, you may have the same flow rate with very low speed.
No. For example, pipeline, if there is mentions 500 cubic meter
For
our
the pipeline.
that is very fast velocity.
Mhm.
So basically, it's considered LNG carriers and LNG fuel vessels when we design bunkering system. So we very careful for consider the pipe sizes because it should not go up.
You should mind that in this situation we have a steady operation because they are equipped in the terminal. It is not something that we move it. It's not. So this is why we have the opportunity to use bigger pipelines with bigger velocity, with higher velocity, and also to be safe. So it's not like having the truck that we have to carry the pipeline from the employees of the company and to do with very careful to do this operation very carefully. It's something which is a more automatic process.
But even so, we will check this and we will confirm it to you. This is also something that you could discuss also with the GPT expert who is going to come on Wednesday.
Yeah.
So we can discuss this even further about the maximum speeds and the protection from formation of any static electricity. Thank you very much. Thank you. very much. Any other questions? Okay. Then, if the students have no other questions, okay, let's thank everyone